Electricity, our most valuable form of energy. No other energy form can be so efficiently and cleanly converted into all other forms of energy for our daily requirements of light, motion, or heat. However, electrical energy has to be transformed again and again on its way from the power plant, the photovoltaic solar module, or the wind turbine to the electrical consumers. This is done with modern power electronics. For example, a photovoltaic solar module produces a DC voltage which has to be converted into the standard 230 volt 50 Hz alternating mains voltage using a solar inverter. On the other hand, your laptop computer requires a DC voltage of a few volts that's rectified and converted from the mains voltage. In many applications, the frequency of an AC voltage has to be modified, such as when the electrical power from a wind turbine has to be fed into the grid with a constant frequency of 50 Hz, despite fluctuating wind conditions. Another example is the frequency converter enabling the speed variation of an electrical motor as required. The role of power electronics is therefore to convert electrical energy as efficiently as possible into the necessary form and to control the flow of power. This is done by means of power semiconductors based on silicon, just like in microelectronics. Power electronics is therefore not restricted to gigawatts and megawatts, but can also be responsible for supplying a mobile phone or heart pacemaker with energy in the milliwatt range. Just like microelectronics deals with processing information, one can describe power electronics as a technique to process energy. The power semiconductors work as electronic switches, while additional passive components such as capacitors and inductors have to buffer the electrical energy. Around 40% of today's overall global energy consumption is electrical energy, and this proportion will continually increase in the next years. One of the key and enabling technologies on the way to a more electric world is power electronics, besides electrical energy storage technology. About 30% of the electrical energy can be saved by consistently using efficient power electronics with standard efficiency levels above 95% for the power conversion. The European Union's ambitious climate goals for the reduction of energy consumption and CO2 emissions cannot be achieved without the extensive use of power electronics. After all, power electronics enables the efficient feeding in of wind and solar power to the grid, the stabilization of the power grids, while the share of fluctuating renewable energies is increasing, highly efficient variable speed motor drives, energy efficient and low emission mobility with electric and hybrid vehicles, energy saving lighting technology, and the efficient energy recovery. Another application for energy-efficient electrical drives is in automotive. This is not only related to the drivetrain, but also to the electrification of the auxiliary units, such as the cooling water pump, the air conditioning compressor, and the power steering. Fuel consumption can be reduced by about 10% with these measures. All of these aspects are challenges that young engineers from various industries work on. At automotive manufacturers and suppliers, at the development and production of electrical drive systems, and at the component suppliers for power semiconductors, passives, substrates, and heat sinks. Intersectoral and multidisciplinary teamwork working towards a common goal, assuring future energy with power electronics.